So empirical and molecular formula exercise. We have a compound which contain like a magnesium compound is there. We have to find its empirical formula. So how to work out the empirical formula? There is magnesium is there, silicon is there, oxygen is there, and their it can be sometimes they can give the percentage, sometimes they can give the mass. So magnesium is 2.73, silicon is 1.58, and oxygen is 3.60. We divide by atomic mass. So magnesium is there, atomic mass is 24, so we divide by 24. Silicon is there 28 and oxygen is there 16. That's a step one. Step one is always divided by atomic mass. So when we divide by atomic mass, 2.73 divided by 24, that's equal to 0.1137. 1.58 divided by 28, that's equal to 0.0564. And this one, it's just 0.23. What is step two? Step two is divided by the smallest value in the combination. So which value appear to be smallest in the combination? We have 0.0564. So we divide all of them by 0.0564. Don't try to round off the answer in between. At the last, it can be done, but not in between. So 0.0564 is there. When we divide, this will be 2, approximately this will be 1, and this will be 4. So in step 3, we normally convert them into a whole number. So it has magnesium 2 are there, so Mg2, silicon is 1, and oxygen are 4. So that's the empirical formula of this compound. Is it clear, this one? The first one? Next is a compound contain magnesium 72% and nitrogen 28. So we have a compound which is having a magnesium and nitrogen. So first, what is the step? The step is divided by the percentage or the mass. By atomic mass, what is given according to the question. So we have magnesium is there 72 and nitrogen is there 28. So we divide by atomic mass. So magnesium is divided by 24 and nitrogen is divided by 14. That is the first step, step number 1. So this will be 3, this will be 2. What is step 2? Step 2 is divided by the smallest value in the combination. So step number 2 is divided by the smallest value in the combination. So smallest value is 2. So when we divide both of them by 2, this will give us 1.5 and this will be 1. So now you 1.5, you cannot just round it off. So what you do, you multiply with a certain number so that all make a whole number. And usually when it is 1.5, 2.5, 3.5, so we multiply all of them by 2. So we multiply all of them by 2. So this will be 3 and this will be 2. So step number 3, it's like making the simplest ratio in a whole number. So which is like Mg3 is there and N is 2. So Mg3 and N2, that is magnesium nitride. Is it clear, this one? Then in this one, the titanium ore contains 36.8% iron, 31.6% titanium, and remaining oxygen. How to work out the remaining percentage? Like, because the sum of the percentage of all the elements should be 100. So if I subtract the percentage of iron and titanium from 100, I'll know how much oxygen is there. So it will be 100 minus 36.8 minus 31.6. And that answer will be equals to the percentage of oxygen in this compound. because the total sum of the percentage should be 100. So that is equals to 31.6. Then to calculate the moles here, how moles are calculated, the percentage divided by atomic mass. The percentage of iron was 36.8 and atomic mass is 56. So that is 0.66. What about the percentage of titanium? That is 31.6 divided by the mass of titanium. So mass of titanium, you will use a periodic table, which is 48. So that will also give 0.66. And then to get the moles of oxygen, the percentage of oxygen 31.6 divided by mass is 16. So 31.6 divided by 16, that's 1.9. Then we need a simplest ratio of the moles. How to take a simplest ratio? Like moles of the iron was 0.66, moles of titanium is also 0.66, and moles of oxygen was 1.98. To take a simplest ratio, we divide by the smallest value. So we divide all of them by 0.66. So this will be 1, this will be 1, and this will be 3. So the simplest ratio is 1, 1, and 3. Whenever you want to take a simplest ratio, you divide by the smallest value in the combination. Then what is the formula of this compound? This compound contains 1 iron, 1 titanium, and 3 oxygen atoms. The next question, 1.68 gram of a phosphorus was burned to produce 3.87 grams of phosphorus oxide. So this is a phosphorus with oxygen and this is only phosphorus. We need the empirical formula of oxide of phosphorus. So either we should have the mass or the percentage. So what is the mass of phosphorus? 1.68. But what about the mass of oxygen? Because this is the mass of phosphorus and oxygen and this is the mass of phosphorus. So how to know the mass of oxygen? We just subtract, like the mass of phosphorus oxide minus the mass of phosphorus, we'll get how much oxygen is there. So it will be 3.87 minus 1.68. So 3.87 minus 1.68 will give us the mass of the oxygen which is there in this compound, which is 2.19. After getting 2.19 gram, we'll do the same method because we need the empirical formula. So step number one is divide by atomic mass. So phosphorus using a periodic table, it will be 31. And for oxygen, it is 16. So when we divide 1.68 divided by 31, so this will give us 0.054. And 2.19 divided by 16, that will give us 0.133 and so on. Then step 2, the step 2 is divided by the smallest value in the combination. So 0.054 is the smallest one. So this will be 1 and this will be 2.5 when we divide. So whenever one of the values 1.5, 2.5, 3.5, because in step 3, we have to take the simplest ratio in a whole number. So what we'll do, we'll multiply whenever 1.5, 2.5, 3.5, we multiply all of them by 2. So 2 phosphorus and 5 oxygen will be there. So the formula of this empirical formula will be P2O5. Then the next, this is another oxide of a phosphorus with the empirical formula of P2O3, means the ratio between phosphorus is 2:3. One molecule of this oxide contains 4 phosphorus. So if there are 4 phosphorus, how many oxygen will be there? X. But the ratio should be 2:3 between phosphorus and oxygen. So we just cross multiply to get the value of X first. So it will be 2x equals to 12 or X is equals to 6. Means this compound contains 4 phosphorus. If there are 4 phosphorus, then there should be 6 oxygen. Why 6 oxygen? As an empirical formula, the simplest ratio between the phosphorus and oxygen is 2:3. So first we work out the formula of the compound. Then the question is not formula. The question is find the mass of 1 mole. So how to find the mass of 1 mole? Phosphorus is 31 times how many phosphorus in this molecule? 4 plus oxygen is 16, and how many of them are 6? So we find the total mass of this P4 and O6, which is 220. So 220 grams will be the mass of one molecule of a phosphorus oxide, which is containing 4 phosphorus and 6 oxygen. How we work out how many oxygen will be there? Because the empirical formula, the simplest ratio is 2:3. So means if 4 phosphorus, it will be 6 oxygen. So the ratio remain 2:3. Is it clear this part? Look, in the question, we have a phosphorus oxide with a formula of P2O3, empirical formula. Empirical formula means which represent the simplest ratio between the atom. So simplest ratio between the atom is 2:3. They are saying what is the mass of a compound which is having 4 phosphorus. So if it is having 4 phosphorus, how many oxygen should be there? So how many oxygen should be there? If the ratio, we want to keep the ratio as 2:3. So if there are 4 phosphorus, how many oxygen will be there? X. We cross multiply. So 2x is equals to 12 or x is equals to 6. So means there should be 6 oxygen if there are 4 phosphorus. And then find the formula mass of P4 and O6, which is about 220. They can also repeat the question. Like example, if I say, what is the formula of a compound which contains 5 phosphorus atoms? Or say 6 phosphorus atoms. So the simplest ratio should be 2:3. So if a compound contains 6 phosphorus, how many oxygen will be there? So 2:3 is the ratio. So 6 phosphorus, x oxygen. Cross multiply, 2x is equals to 18 or x is equals to 9. So it means it should be P6 and O9. So the ratio remains 2:3. Is it clear this part? The next is many organic compounds contain carbon, hydrogen, and oxygen. We have to work out the empirical formula. How to work out the empirical formula? We have carbon, hydrogen, and oxygen, and their percentages are there: 48.65, 8.11, and 43.24. The first step is divide by atomic mass. So this will be 12, this will be 1, and this will be 16. So 48.65 divided by 12. This will give us 4.05. This will remain as 8.11, and this will be 2.7. Step 2 is divided by the smallest value in the combination, which is 2.7. So 2.7, 2.7, 2.7. When we divide, this will be, this will be 1.5, this is 3, and this one is 1. Whenever one of the value is 1.5, 2.5, 3.5, what we do? We multiply by all of them, not only one. We multiply all of them by 2. So this will be 3, this will be 6, and this will be 1. Sorry, this will be 2, because multiplied by 2. So the empirical formula, what is the empirical formula of compound? C3H6O2. Then compound W has an empirical formula of CH4O, and the relative molecular mass is 32. What is the molecular formula? If you want to work out the molecular formula is empirical formula multiplied by N. And what is N? N is the molecular mass divided by empirical mass. Molecular mass is 32. How to work out the empirical mass? Empirical mass is always from empirical formula. So it contains one carbon, it contains four hydrogen, and it contains one oxygen. So 16 plus 4, 20 plus 12, 32. So empirical and molecular mass are same. So it means N is 1. So molecular formula is empirical formula times N. So empirical formula is CH4O, and the value of N is 1. So this 1 will be multiplied with carbon, multiplied with hydrogen and oxygen. So it will become CH4 and O. So that's the molecular formula of the compound. So when empirical formula, and when molecular mass and empirical masses are same, that compound will have the same empirical and molecular formula. Is it clear this work? The next is compound X and Y have a same general formula. Look how we generalize the result. If a compound have two carbon, it has four hydrogen. So hydrogen become double and oxygen remain two. If it is having four carbon, it has eight hydrogen, but oxygen remain two. So how we can generalize this? If we say a compound contain n carbon, how many hydrogen will be there? Because always the hydrogen is double. So if there are n carbon, how many hydrogen will be there? The hydrogen will be 2n. Because it will be double. But what about oxygen? Oxygen, you can see it does not depend on carbon and hydrogen. It remains 2. So oxygen will remain 2. It won't change because this compound was having 2 oxygen. The other compound also have 2 oxygen. So it means the oxygen number does not depend on the carbon or hydrogen number. So we'll write as a general formula as Cn H2n O2. Why O2? Which shows that the oxygen number does remain 2. It is independent of the number of carbon and hydrogen. So oxygen number is not even double, not in triple. Even like example, if I say another example, I say C3H6O2, C4H8O2, C5H10O2. So what is the general formula? Oxygen number is not changing. It is independent. So O will be 2. But hydrogen number is double of the carbon, like 3 become 6, 4 become 8, 5 become 10. So if it is N, this will be 2N. So Cn H2N O2. Then a fluorine react with sulfur to form a compound which is 25% sulfur is there, 25.2% sulfur is there, and we need the molecular formula. But to get the molecular formula, you need empirical formula because you cannot get the molecular formula directly, as a molecular formula is empirical formula times n. So first thing we need empirical formula, then we need n, and then we multiply to get molecular formula. So first thing we'll find empirical formula. How to get empirical formula? We have the percentage of sulfur 25.4. What will be the sulfur of fluorine? Because they mention a fluorine react with sulfur. So if 25.2% sulfur is there, remaining of the compound will have fluorine. So 100 minus 25.4 will give us the percentage of the fluorine in this compound. Because the total percentage should be 100. So simply what we will do, we will subtract from 100. So this will give us 74.8. Now step 1, divide by relative atomic mass. So sulfur is 32 and fluorine atomic mass is 90. So 25 point, this is 25.2 divided by, so this will become 0.78 and this will be 3.93. Then we divide by the smallest value in the combination. 0.78, 0.78. So this will be about 1 and this is 5. So 1 and 5 are there. So what is the empirical formula? Empirical formula, we work out SF5. Now to work out the molecular formula is empirical formula times N. And what is N? N is molecular mass, which is 254, divided by empirical mass. Empirical mass is from empirical formula, because the value for N is the molecular mass, relative molecular mass, divided by relative empirical mass. So molecular mass is given 254. Empirical mass is how much? Sulfur is 32 plus 9. Fluorine is 19 times 5. So 19 into 5. So it will be 85. And then sum them. So it will be 127. So 254 divided by 127. N is equals to 2. So we get the value of N is equals to 2. So we have the formula. Molecular formula is empirical formula times N. Empirical formula is SF5 and N is equals to 2. So this 2 will be multiplied with sulfur. It will be multiplied with fluorine. So it will be S2 and F2 multiplied by 5, 10. So S2, F10. That's a molecular formula. Is it clear, this one? Then a compound X is there. A compound X is there, which is having 55.85, 6.97 in percentage hydrogen and 37.18% oxygen. How does it prove that compound contain carbon, hydrogen, and oxygen? How we know that these are the only element and there is no other element? So when we sum them, like 55.85 plus 6.97 plus 37.18. When we add, the total percentage should be 99.9 or 100%. Like the sum should be either 99 or 100. Means there's no other percentages there left that shows that other elements are there. All the sum of all these percentages will give us like 100%. Use the above, calculate the empirical formula. So how to work out the empirical formula? We have the percentages. The same manner we will do. So we have carbon is there, we have hydrogen is there, and oxygen. Carbon is 55.85%. Hydrogen is 6.97%, and oxygen is 37.18%. Step 1, divide by atomic mass. So this will be 12, this will be 1, this will be 16. Step 2, like after dividing, that is step 1. (55.85) divided by 12. So this will be 4.65. This will be 6.97, remain same, and it will be 2.325. Then divide by the smallest value in the combination, which is 2.325, 2.325, 2.325. This will be 2 about 2, this is about 3, and this is 1. So we don't have to round off now. So it will be C2, H3, and O. That's the empirical formula. Then C3, C2H3O, then we need a molecular formula. And the molecular mass is given 86. So if you need the molecular formula is empirical formula times N. Empirical formula is how much? That is like the CH3, C2H3 and O was there. That's the last answer. And multiplied by N. How to get the N? N is the molecular mass, 86 divided by empirical mass. Empirical mass is from empirical formula. So carbon is 12 multiplied by 2 plus hydrogen is 1 into 3 plus oxygen is 16. So 86, this will be 24 plus 3, 27 plus 16. So 43. So 86 divided by 43, N is equals to 2. N should always be a whole number. So value of N is equals to 2 here. This 2 will be multiplied with all of them. So this will become C4H6O2. So C4H6O2 is a molecular formula. So a sample of isoprene had the following composition, carbon and hydrogen. You have to work out the empirical formula and what additional information is needed. If you want to find the molecular formula, we need the molecular mass is needed. And how to work out the empirical formula. So it contains carbon and hydrogen. Carbon is 88.24 and hydrogen is 11.76. So we divide by atomic mass, this will be 12, this will be 1. So 88.24 divided by 12, that's 11.76. That's 7.35. Yeah, 7.35. And this will be 11.76. Then we divide by smallest value, 7.353, 7.353. Then this will be 1 and this is 1.6. Now it is 1.6. Again, the problem is we cannot round off. So what we do, we multiply. Like now one of the values 1, another one is 1.6. So how to know which number to multiply? If you don't understand this multiplication factor, just try with all the numbers. If I multiply by 2, this will be 2 and this will be 3.2. It's not giving me the whole number. So I should not multiply by 2. Then what if I multiply by 3? If I multiply by 3, this will be 3, but this will be 4.8. Again, it's not a whole number. Because after multiplication, we should not round it off. We want a whole number. So it's not even 3. If I multiply by 4, this will be 4. And this will be like 3.2 and then 6.4 will be there. So it's not a whole number. But if I multiply by 5, this will be 5 and this will be 1.6 multiply by 5. So it's make 8. So I should multiply them by 5. So the simple rule is you check with 2, then 3, then 4. Just multiply with the number which gives you a whole number. That is a multiplication factor. So this will be, we multiply all of them by 5. So this will be C5 and H. It will be there. Then in question 9, we have crystals of copper are there. A compound contain copper, chlorine, hydrogen, oxygen. Copper is 37.43. Chlorine is 41.52. Hydrogen is 2.34. And oxygen is 18.71. We divide them by atomic mass. So copper is 64, chlorine is 35.5, hydrogen is 1 and oxygen is 16. After dividing them by atomic mass, 0.584 for copper. Okay. So 37 divided by 64, that is 0.584. 41.52 divided by 35, so that is 1.169. This will remain same. And 18.71 divided by 16. So about 1.169, I guess. Then this one is we divide by the smallest value in the combination, which is 0.584. So divide all of them by 0.584. This will be 1.169 divided by 0.584. That will be 2. 2.000. That's 2. This one will be 4. And this one is 2s. So it compound contains Cu, Cl2, H4, O2, or O2, yeah. So it's the same manner, same way we work out. We divide by atomic mass, then we divide by smallest value, and then we make the simplest ratio in a whole number. Sulfur dioxide react with sodium sulfide to give a compound which is having 29% sodium is there. Sulfur is there, 40.5% sulfur. And oxygen is there, which is 30.4. Step 1, divide by atomic mass, so 23. Sulfur is 32. Oxygen is 16. 1.265, the first one. The second one. 1.265, it's the same, okay. And the third one is about 1.991. And then we divide by the smallest 1.9 is there, okay. Then we divide by the smallest value in the combination, which is 1.265. 1.265, 1.265. So this will be 1, this will be 1, but the problem, this is 1.5. So this is 1, 1 and 1.5. So it's the same multiplication factor we use. So first we start with 2. Look here, when we multiply all of them by 2, we are getting a whole number with a 2 only. That's why we don't multiply with any other number. So this will become 2, 2 and 3. So the formula will be sodium will be 2, sulfur will be 2 and oxygen will be 3. Question 11. We have the percentages. So we work out like we have carbon and hydrogen. First, we work out the empirical formula of a compound. 85.7% carbon and 14.3% hydrogen. We divide by atomic mass. So this will be 12. This will be 1. 85.7 divided by 12. That's 7.14. 7.14, and this will remain 14.3. Then we divide it by the smallest value in the combination, which is 7.14. 7.14 when we divide. So the ratio, this will be 1 and this is about 2. So the empirical formula is CH2. So empirical formula is CH2. Now molecular formula. So molecular formula is empirical formula times N. So it will be empirical formula CH2. But what about N? N is a molecular mass divided by empirical mass. Empirical mass is 1 carbon and 2 hydrogen. So 12 plus 2 makes 14. So 112 divided by 14. So that will make 8. So N is equals to 8 here. So this 8 will be multiplied with carbon and multiplied with hydrogen. So it will become C8 and H16. Then the last question. A sample is there of a rust. Calculate the moles. How to get the moles? Mass in gram over molar mass. So 51.85 divided by 56. Oxygen atom 22. If it was oxygen molecule, we divide by 32, but oxygen atom we divide by 16. And for water, 16.67 divided by hydrogen is 2 and 1 into 2 and plus oxygen 16. So total is 18. This will give us the moles of each of them. That is 0.92, 0.926, 1.389, and then 0.926. Then simplest ratio. How to take a simplest ratio? We divide. If you want to take a simplest ratio, like between 0.926, 1.389, and 0.926, we divide all of them by the smallest value, which is 0.926 in this case. So this will be 1. This will be 1 will be there. This one is 1.389 divided by 0.926. What's the answer? So it will be about 1.5 and this one is 1. But because 1, the simplest ratio should be in a whole number. So we multiply all of them by 2. So this will become iron 2. This will be 3 and this will be 2. And what is the formula of the rust? It contains 2 iron. So we write Fe2. It contains 3 oxygen. So we write O3. And it contains 2 water molecules. So 2H2. That's a formula for rust, which is hydrated iron 3 oxide. Is it clear, this one? That was the last question from this exercise. Empirical formula. Any question or a doubt?